as we start looking at segments inside circles, remember last class we looked at angles in circles. There are different relationships now between the segments inside of a circle instead of the angles inside of a circle. So on your green formula sheet, you used last class the side that said angle relationships. Flip it over onto the back. There's going to be 3 columns on the back there. These are the relationships between the segments, and that's what we're going to be studying today. The first relationship we're going to study is this segments inside the circle. So if you notice the definition right here, we have a circle where the segments are intersecting inside the circle. So we're no longer looking just at the angles and the arcs. We're going to be looking at the segments. Now, the relationship between these segments that are intersecting in the circle is as follows. Part 1 multiplied by part 2 will be equal to part 1 of the other chord multiplied by part 2. And to make this make sense for us and match the formula chart that I gave you, you're going to change this number 1 to a 3 and this number 2 to a 4. That way, when you look at this image, you can see that we are going to take part 1 and part 2, which come from the same chord cutting across the circle. See how this is part of the same chord? Part 1, part 2. Then you're going to set that equal to the product segment 3 times segment 4. So you're like crisscrossing across the circle, but 1 times 2 is equal to 3 times 4. This is why we're color coding, because it makes sense when we see the colors on our paper. So 1 and 2 are part of the same chord. 3 and 4 are part of the same chord. Now what's going to happen most likely is that there is going to be a missing part, a missing segment, and you're going to have to figure out the length of that segment. So for example, in number 1, it says to find the value of x and the length of each segment. So I notice right away, my eyes go to the circle, and I notice that this is intersecting inside the circle. So I start color coding. I say, all right, for this first segment, here's the first part, here's the second part. For the second segment, we have the first part and then the second part, so parts 3 and 4. If you look at my formula I set up, I did the first part times the second part, and I set it equal to the third part times the fourth part. Do we see how I set that up? I took the numbers and the letters from the image and I put it in my formula, part 1, part 2, part 3, part 4. Yes? After you do that, you're done with geometry. And then it's just a various algebra problem. It might be something complicated enough to need a box method, or it could just be a quick little inverse operations. So for this one, where did the 45 come from? Any ideas? Where did 45 come from? 9 times 5 is 45. Check. Where did the 3x come from? 3 times x. Okay, cool. So I literally just multiply the stuff together. And then I solve for x by here. I divide by 3 on both sides. I get that x is 15. So that's my first blank. X is 15. This question also asks for the length of the segments. Segment AB is this one right here, which means I'm going to do 15x. 15 plus 3, which is 18. And then CD is this guy, so that's going to be 9 plus 5, which is 14. Do we understand? What are our questions before we move on? If we see another example here, we have segments intersecting inside the circle. So I look at the inside circle formula and notice I need 4 parts. I need part 1. That is not decimal 15. That's just a rogue dot. That's just a 15. I need part 2, which is 5x minus 2. I need part 3, which is 7x. And I need part 4, which is 10. Notice again that part 1 and 2, my red and my blue, are on the same chord, and my green and purple are on the same chord. This time when I start to solve, because again, once you fill in that formula, you're done with geometry, you're just doing algebra. Again, this is not decimal 15, that's just a rogue stray mark. We'd have to take this 15 and multiply it inside this parentheses. We have to distribute. 15 times 5 is 75, and then 15 times negative 2 is negative 30. 7x times 10 I multiply together. 7 times 10 is 70, so this is 70x. After that, I solve for x, and this one I showed the box method, so you had some nice box method practice on your paper. Organize the way we need to, combine like terms the way we need to, and divide the way we need to. We get that x is equal to 6. That's my first blank. Now it goes back and it does ask us to find the length of each segment. So AB is 15 and then 5x minus 2. But instead of writing x, what do I put in its spot? 6, what I found for x. Throw that in a calculator, you're going to get 43. Same thing for CD. I do 10 plus 7 times x, but x is 6. Throw that into a calculator, and bam, you get 52. Does that make sense? So when the segments intersect inside the circle, you're setting up this formula right here, where you have the 4 parts, 2 parts multiplied together, 2 parts multiplied together, set equal to each other. Check. Then it's going to change. If you notice, this time we have secant lines, so they're going outside the circle, which means they're no longer chords, they're secants, but they are intersecting outside the circle. The formula changes. This one is a little bit more complicated. So let's get our color coding together. For this one, it says the formula is to take the outside part, okay, outside part, so like this part. Do we see how that's outside the circle? The segment that's outside the circle? And then you're going to multiply it by the whole thing or the entire segment, which means I'm going to have to add these 2 pieces together because I want both pieces. So there will be a little addition problem in there. Then you're going to set it equal to the other outside part, outside, multiplied by the whole other part. So that would be this entire segment. So again, you're going to have a little addition problem where it says whole or all because it's 2 parts. We're just adding them together. That might be helpful for us to write down here that for the blue and for the purple, we have to add them together. For the green and for the red, you just get to take the number from the image or take the letter from the image. So let's see an example here. In number 3, I notice that the segments are outside the circle. They intersect outside the circle. So my brain goes to the outside circle formula, which says I'm going to take the outside part, which is 9. Do we see that? We agree that that's outside. I'm going to multiply it by the whole secant line, which is all of this. I need both of those numbers. What is 9 plus 11? Ooh. 20. So see how I put this 20 right here where it says all? That's because I did 9 plus 11. So here, and maybe you need to make a note to yourself since I didn't quite show my work. That might be helpful. This is 9 plus 11, which is both numbers written on that blue part. Then I switch to the other secant line. I want the outside part. What number is on the outside of that secant line? 10. So I put a 10 right there. And then in the next parentheses, it says it wants all. What are the 2 numbers, or number and letter, that are a part of the whole thing? 10 and x. So look at what I wrote down. I couldn't just write 10x. I had to add those together the same way we added 9 plus 11. They're just not like terms, so we leave it as 10 plus x. Do we see that? Okay. After this step, you're done with geometry and you just have to do some algebra. Now, if you notice, I showed my work here. This is a distribution question. So I do 10 times 10, which is 100. 10 times x, which is 10x. Where did this 180 come from? Nine times 20. Those two numbers are smushed next to each other. It means multiply. We get to 180. We box method. We understand. We divide by negative 10. We get 8. So the value of x is 8. Then it asks me for the segments again. What is the length of RQ? Well, RQ is this whole thing, or all of it. What did we say all of it was? 20. For RT, because the whole thing was 10 plus x, I then have to use my x value in here, so it's 10 plus 8 to get 18. Do we follow along? Okay. Just to show you another example here where there's a little bit more distribution going on, let's see if we can highlight the setup. Outside number. For the first or the top chord, what number is outside? 15. So I put a 15 in that parentheses. For that same top secant line, what are the two numbers that make up the whole thing or all of it? 3x and 15. So we have to add those two numbers together. 3x and 15. They are not like terms, so we leave them with the plus sign showing 3x plus 15. On the other secant line, what number is outside? 20. And then if I look at the whole thing, what is all the numbers on this line? X and 20. Now, after we set it up, it's just an algebra question. Since both sides have a plus sign in that second parentheses, we're going to have to distribute this number in front. 15 times 3 and 15 times 5 gets us 45x and 225. 20 times x and 20 times 20 is 20x and 400. We box method. We solve for x. Once we have x solved for, we want the lengths of the segments. So what did I do in both of these little workouts right here to get the lengths of the segments? What did I do here? Plugged in the x. Very good. Exactly where it goes in the whole or the all part, I plugged it in so I could get the length of that segment. So do we see, before you flip it over, hold on. Do we see that there's a different formula for when it's inside, part 1, part 2, part 3, part 4, and when the intersecting point is outside? Do we see that? Yes. Okay, I see heads nodding. Now flip it over. You flip yours over. I'm going to leave mine on this side. What is the difference between the image on the back there and this circle and intersecting chords? Can you tell me what the difference is to the picture on the back? Okay. Right idea. This one's not a diameter though. What is this called? When it's half of the diameter? Radius. Now what I really wanted us to notice is that there is no longer two secant lines. This one is a secant line, but what kind of line is this where it only touches it once? A tangent line. Very good. So this is going to feel different. Because it's a tangent line, we actually have to use a different formula. It's really the same formula, just doubling one of the segments, but we're going to treat it like it's a separate idea. When we have a tangent line outside the circle, okay, technically we can use the same idea for secants, but we're going to call it for tangent lines outside the circles. The formula is as follows. You are going to take the outside part. This sounds familiar. The outside part. And you're going to take the whole or the all part, which is all of that secant line. That sounds familiar. That's what we did before. But if you notice, the other line doesn't have an inside and an outside part. It's like entirely outside, right? When it's entirely outside, because it's a tangent line, you are just going to take this value and you're going to square it. Make sure you see that squared right there. You have to square the tangent. Okay, let's see what this looks like. It's going to feel just like the problem we did before, but maybe a little bit more challenging. So in number 5, I noticed that it's intersecting outside the circle, but that CA is a tangent line. So I use the tangent formula, which says I'm going to take the outside part, which is 5. I'm going to take the whole part of that segment, all of that segment, which is what plus what? Five plus x. And then I'm going to set it equal to the tangent part squared. What number is on that tangent line? 10. Now remember, squaring, if you don't know how to square in your head, there's a button on the calculator, but it is not times 2, it is 10 times 10. So when I stop doing geometry and start doing some algebra within this geometry problem, I notice on the left side I have to distribute because I've got a plus sign. So that's 5 times 5 and 5 times x. And then on this side I have to square it. It is not doubled, it is squared. 10 times 10 is 100. But after I do that part, it's just a simple solving for x. Once you get done with the distribution and the squaring, just like the front, it's a simple solve for x. To finish out this problem, it asks me for x and the segments. Well, x is 15. Segment AC, I don't have to do anything crazy. It just says 10. It's 10. But for CB, I have to use x to find the length of CB. We found that x is 15, so 5 plus 15 is 20. Before we look at the next example, are there any questions? Okay. For the next problem, number 6, this is really complicated, but ends up being really easy. So if we set it up the way that we know how, we have the outside part, which is x. You see how x is straight up outside on that secant line. Then we have the whole thing, which is 12 and x, so I put 12 plus x. That's for all of it. But instead of there being just a plain number on the tangent segment is also an x value. It's x plus 4. When you have x plus 4 as your tangent, or something with x as your tangent, you're going to slow down because this one's going to get a little bit more complicated. I showed my work here off to the side. And if this says x plus 4 squared, remember that doesn't mean times 2, it means x plus 4 times x plus 4, which I wrote right here. Now all those arrows are going crazy. What am I trying to get you to do with all of these arrows that are happening right here? Double distribute, multiply. So I take the x and I multiply. I take the 4 and I multiply. That's called double distribution or FOIL. We've done this before, but it's been a minute. So x times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. 4 little multiplication problems. Now this looks pretty scary because when I distribute this side, x times 12 is 12x, x times x is x squared. When you have an x squared term, it's technically a quadratic function. But since we have an x squared term on both sides that are both positive, they're going to cancel each other out. Subtract x squared from both sides, it cancels out. We've seen this before in another part, I think it was in Unit 7, where we ended up with a quadratic, but it canceled out, so that's easy. We cancel it out, which means we only have numbers, oops, didn't mean to do that. We only have numbers and x values left. We box method, we solve for x. So it has a moment here where the algebra is a bit more complicated than normal, but we go ahead and still solve for x. We get that x is 4, check. AB is 12 plus 4, 16. And CB is 4 plus 4, 8. That problem was a little bit more complicated, but many of these problems will just have numbers on the tangent line, like this one, instead of x values on the tangent line like this one. Okay, now this last little bit was left on here for honors classes, but I went ahead and showed you what the math would be. It's got some algebra that I don't need us to necessarily practice unless you're going into an honors class next year. If you are, you should probably make sure you remember how to do this factoring section because your honors teachers are going to expect you to be able to do that. However, you can always ask for help. I have it here for you. The only thing I want to do on these problems, because I'm not going to ask you problems this hard, but let's just make sure we understood the setup. So we're only going to look at like this part right here. For number 7, which formulas do I use? Do I use the formulas for where it intersects inside, outside, or outside with a tangent?
Outside with a tangent.
There's a tangent in this one? Tangent means the line only touches a circle once. No, we're just going to use the regular outside formula. So the outside formula is the one where it's outside all, outside all. I have it written there for you. So if we highlight this one just to make sure we understand, the outside part of the top secant line is x, which means the whole thing or all of it is 5 and x. For the second segment, the outside part is 3. And all of it is 9 plus 3. Do we understand that setup? The solving, like I said, if you're going to an honors class, I do need you to look through that. Make sure you remember from Algebra 1 or Algebra 2 how to factor. But for the most of us who are going to Algebra 2 next year, especially my sophomores, you will be reviewed factoring significantly in that class. For number 8, let's make a decision. Which formulas should I use? Inside, outside, or outside with a tangent? This one is outside with a tangent. Notice how this bottom part that says 20 only has one number or letter on it, and it touches the circle only once. So the formula I'm using for this problem would be the outside, which is y, multiplied by the whole thing, or all of it, which is 30 and y, equal to the tangent squared. So that's going to be 20 squared. Again, for this one, because the algebra requires factoring, I'm not going to ask you questions with this algebra in it, but if you are going into honors, make sure that you've looked through it, and I can answer your questions about it individually. The first goal in all these problems is to make sure you pick the right formula, kind of like what we did for the angle relationship. So we're good at that. You've got a formula chart in front of you with the 3 options, so you can see the formulas over and over again and solve for x, which we're really good at.